All right, so let's talk about some of the processes that are actually lowering Gibbs free energy, right? What kind of reactions are happening? The first type of reaction could be recrystallization. We call metamorphic processes recrystallization if the mineralogy doesn't change, right? Whatever mineral you start out with, you end with. What does change is the texture and size of those new crystals. So maybe you start out with a whole bunch of small quartz crystals and end up with a lot of large quartz crystals, right? That's recrystallization. So changing the size and the shape of the existing minerals. Neocrystallization is when you get brand new minerals, neo meaning new, right? So the mineral composition does change here. The old minerals, maybe you start with plain quartz, become new minerals under those new environmental conditions, and the new minerals that form are going to be more stable in those new environmental conditions. So maybe you increase temperature and pressure, and now you get garnet and mica added, which are more stable at high temperatures. Neocrystallization when you make new crystals, new minerals. Now you can also have a pressure solution. This is when say you start with a spherical grain originally in the protolith, and then you put it under intense pressure, right? As those grains are put under pressure, especially if it's differential pressure, right? A lot of it coming in from two different directions, the inside of those minerals might stay the same, but the outside of those minerals are going to turn in what we call a pressure solution, where the surface undergoes a solid state solution, dissolving and migrating away, so that you end up with elliptical grains, right? So the inside of the grain doesn't change, but the outside of the grain undergoes that solid state solution, pressure solution process. Now, something similar to this, but a little different, is what we call plastic deformation. Here, again, you're starting with spherical grains and you're ending with elliptical grains, but now it's not because of the outer edges of those grains changing. Now it's because the whole grain was pushed and squeezed and elongated. So here, even the inside of the grains become plastic and begin to flow. Now, each mineral, each rock has a variety of different properties that allow minerals to favor different types of metamorphic processes, right? Some minerals are more likely to recrystallize. Some minerals are more likely to undergo plastic deformation. And because of this, if you take a rock that contains many different minerals and you put it under intense heat, pressure, and or hot fluids, the different minerals are going to react differently. So here you can see that the thin black and white stripes were minerals that underwent deformation very easily, whereas those like semi-rounded chunks of what kind of looks like garnet, that didn't deform very easily, right? That was fairly stable. And it creates what we call boudinage. It kind of looks just like a series of sausage links. And those sausage links are the part of the rock that didn't deform as easily as the other parts did around it.